Hey, CPO here, and getting through this helicopter build, getting ready to finalize the mounting of all of my electronics. I've got all of my wires bundled in, and I know where they're going to go. And basically, I'm getting to that point now where I need to program my ESC. So as you can see here, I have the YEP 45 amp. You may have seen that from my other videos. I'm going to start the process of getting it set up. I do have the program card for this particular ESC, and so I'm just going to go through getting it set up, doing the programming that I need for my particular build so that I can plug everything back in and then get it basically hard mounted into the helicopter. So before I button down all of these electronics, I do want to make sure that I've got the ESC programmed, because it requires unplugging the ESC from the fly barless system and then using this jumper cable that comes with the program card to kind of go back to the fly barless system. And the reason is there are a couple places where I need to set the throttle low position and the throttle high on my Spectrum radio. So because of that, we'll need to have the card connect to the fly barless system, or a receiver if you choose to use that method. So to be honest with you, I'm not sure exactly if I need to program in the stop and full speed settings if I'm not using the governor mode, but I think I do, and the reason is I have a cutoff type, so it's going to slow down. So perhaps it uses the throttle positioning to do that. At any rate, I'm going to go through that process. I'm not using the governor, so a lot of these settings on page 2 I'm not going to get into, but I'm going to set the things that I need for my particular heli build. So with that said, let's get started. So the first thing that I'm going to want to do is get my ESC plugged in to the program card here. So as you can see, there are two plugs here. Indicates brown to the right, so that's the ground side. In this case, all of the wires that have grounds are brown. And then you can see kind of underneath these pins here, it says ESC or RX. So first of all, let me show you what I do have connected. My ESC is connected up to the motor. I have to be really careful here. Disclaimer, I don't have the shrink tubing yet on two of these wires for my motor. I've got the blue one shrink tubed and ready to go. I haven't yet decided if this is yet running in the right direction or not. So when I plug in the motor, I have a 50-50 shot of having it spin in the correct direction, and if it's spinning backwards, I need to reverse the wires. I want to wait until I know if it's spinning in the right direction before I put the shrink tubing on, so that I can color code match it, so that once I've decided what the right orientation is, the color coding will be my guide. So just know that I've got these kind of bare connectors here, so I'm paying a lot of attention to make sure that they stay separate from one another and they don't touch each other. The other thing is, I don't yet have the battery plugged in to the ESC, so that's important to note. And then the ESC, of course, is not plugged in anything else. Additionally, I don't have any blades on my helicopter. I don't expect the motor to spin up during this process, but if it does, my tail blade is clear of anything, and my rotor is clear. You know, a good precaution to take would be to completely, you know, either back the pinion gear off of the main gear, or take the main gear off. But like I said, for the purpose of this procedure, the motor should not actually spin. I do want the motor connected though, because I'm going to get beep responses from the motor to show that it's being programmed properly. And it's my understanding the process goes a lot smoother if it's connected to a motor. So again, I've got these 3 motor wires. Very careful to make sure that they don't touch. As a matter of fact, you know, it's only going to take a second. Here's what I'm going to do. I'm just going to wrap these just to protect them from accidentally touching each other. It'll only take a second. And then even just in a temporary state, I can be assured that I'm not going to accidentally short these wires out. And in my opinion, it's just a little extra benefit with a lot of potential gain if I protect myself from something silly. So there we go. So now those are protected, and there's no chance of me shorting them out during this process. All right. So the next thing I want to do is I want to go ahead and plug my ESC cable into the ESC port here. ESC is this one, and I want the brown facing right, just like that. Hopefully you can see that just fine. And then I'm going to go ahead and plug in my lead that came with the ESC programming card. I'm going to plug that in to the RX port also with the brown to the right. Okay, so that's how that's going to go. I'm going to check my radio, make sure that my stick is in the low position, and go ahead and make sure now that I don't have throttle hold engaged. I want throttle hold off. So that way when I get through this process, I'm not limited by that throttle hold. Additionally, you want to make sure that you have linear programming, 0 to 100 in the in your chosen model. So I need to go, I'm going to do this real quick here. Need to go to model select, pick my taro. So make sure you're working in the right model if you do this, otherwise you may miss something. And then throttle curve, as you can see, I'm just a straight linear curve. So that's where I want to be for this, just to make sure that I'm getting everything set correctly. So I'm going to go ahead and set that aside now. Now I'm going to go ahead and plug in the LiPo. This is where things get scary for me, because when I start adding in power, if I miss something, this is where it becomes apparent. But I think we're good to go. Again, I'm just doing a quick double check because I'm kind of ridiculous that way. I've got my motor wires not touching and connected. I have the ESC plugged in to the card, and then the receiver port plugged in but not connected to the receiver yet. I want to let this card initialize before I do anything else. So once I plug in the battery, we're going to see this some lights on here as this program card initializes. So I'm going to set that right here where you can see it. This little page is kind of getting in the way, so I'm going to open it up so it's out of the way. We can make sure we see these initialization lights. Matter of fact, I'm going to fold it under. Alright, and then I'm going to plug in the battery. Okay. So what I got was a little startup tone and do-do-do-do-do, and then hope you like that. I'm probably not going to ever do that again, so I hope you enjoyed it. And then we saw some initialization with the lights here. And basically what it is doing is showing me some of the current settings. So now that that's initialized, I'm going to plug this into the fly barless system, into where I would normally plug in the YEP. So I'm just going to reach in here, And with that said, I don't know if you can see here, I have now the fly barless system. As a matter of fact, that should be good to go there. And this I believe the Robird should be initializing. Yeah, there we go. So now I am up. It's actually showing a connection to my transmitter, and when I move the transmitter, I get movement on the helicopter. So that is that. It's going to be a little noisy because it's kind of hanging off to the side there. Alright, so now we can go back to this. Start my programming. So I'm going to start on page 1 here, and then we're just going to go through this thing a piece at a time. Alright, so the very first thing that I'm presented with on page 1 is going to be timing. Now timing is recommended to me to start out at 18 degrees. So 0 to 12 is for an in-runner motor, 18 to 30 is for an outrunner motor. Outrunner motor in the helicopter means that the motor, the outside of the motor turns as opposed to the inside. So that's how you can tell it's an outrunner. How you adjust this, we actually have 3 buttons on this programming card. This top button controls the movement across the top. Okay, and this bottom corner button controls the movement across this side axis, which is what selections you're making. Okay, so now I'm back to timing and I'm back to 18 degrees, and then this enter button is where I will select whatever settings I choose. So for this, I'm going to start with an 18 degree timing, and that's where it defaulted to. And lucky me, that's where I want it. So I'm going to go ahead and hit enter. I get a tone beep indicating that it accepted that programming into the card, and then I can move on to the next one. So I'm going to go down to brake. Brake I want off for a helicopter. Generally the recommendation, I believe, is no braking on the helicopter, and that is the default position here on the card. So I'm going to hit enter just to be safe, and then I'm going to scroll down, and I have next is cutoff type and the battery type, basically. So as you can see here, now I have 2 red lights because I have 2 different selections to make here. So on the first one, my cutoff type is set to slow down to default, which is actually where I want it. I don't want it to just cut off on me mid-flight. I would rather it slow down for me, but I do want some protection for low voltage. So slow down is where I want it. If I chose to change that, I could just manually move it to wherever I want it, slow down, and then hit enter, and then go to my other selection, which in this case I am using LiPo batteries, and it defaulted to that as well. I can hit enter there as well. Now when I go back up to that, oops. So I had to double check on this just to make sure, because I was kind of concerned that I had everything set right. But basically when I first went to this row here with cutoff type and the battery type, I had both slow down and LiPo selected. It was showing me the default options. Once I changed from default, now I only see 1 at a time. And it looks like that seems to be fairly normal. So I'm going to keep rolling. I kind of expected once I selected them both that if I scrolled through and got to that again, I would see both selections. But it doesn't look like that's the case. So anyway, I just wanted to verify that. So again, I'm just going to make sure that I still have this. So slow down, enter, which is what I want. And then LiPo is the battery type that I want. So now I can move down to cutoff voltage. Cutoff voltage, the default is 3.1. Okay, so here's something interesting that's important to know. There's 2 rows of voltage indicators. There's the top row and then there's the bottom row. The bottom row is your choices if you're using LiPo. The top row is your choices if you're using Life. And nickel metal hydride doesn't have an actual cutoff voltage selection option. So that was good for me to find out, because I was thinking this was a range like 2.4 to 3.1 or something crazy like that. So if you've selected LiPo, you're now only looking at this bottom number. It defaults to 3.1. That seems to be a fairly common cutoff point. Some people will recommend going up to 3.4, getting as high of a low voltage cutoff as you can. The reality of it is 3.1 is probably okay. Anytime you start getting down into 3 range, you start getting nervous about your battery. But the key is you don't want to use cutoff voltage as a indicator of when to stop flying. You should have stopped long before it gets down to this point anyway. So this is kind of an emergency thing. So I'd rather make sure I have enough room on the voltage side of things before I hit emergency level. So I'm going to leave it at 3.1. I know that some people will recommend going as high as 3.4. I'm gonna leave it at 3.1. You do what you want to do. And then I'm going to use my timer and aggressively figure out how much time I can fly, and use that timer to establish my flight times. So I'm going to go down. Number of cells. I need to pick 6 because I'm running a 6S. So I'm going to go here to 6. And I need to hit enter. Okay, confirmation. Now I can ignore this one. There's 2 rows of cells. If I picked a selection on the first one, I don't have to worry about the second one. All right, and then if you have less than 4 cells, it will automatically detect the number of cells. So that's why you only see it starting at 4. The next thing I want to do is look at special functions. So I have short beep. That if I want to shorten the beeping startup sequence, you can do that. I'm not going to worry about it. The Rev Navy is for specific type of ESC that I don't have, so I'm not worried about that. You'll probably know if you do. And the next one is the stop and full speed, these 2 settings, and that's where you need your transmitter for. So I'm going to grab it over here. Again, make sure throttle hold is off. And make sure that the throttle's in the low position. And then what I'm going to do is scroll to stop, and then hit enter with it in the stop position. Then I'm going to move my throttle to the high position, and then I'm going to go to full speed and hit enter. And then that's all I need to do really with the transmitter. F3A brake is for that particular circumstance, those planes, not worried about it. And then auto timing, if I decided not to use this 18-degree timing, you can use auto timing. It's questionable how good auto timing works. I'm going to go with the recommendation to use 18 degrees for now, and I can adjust from there. So next is going to be page 2. So to get to page 2, we have to flip our page over so that we can see these other options, and then we have to tell the card that we've actually switched to page 2. And to do that, you press these 2 buttons simultaneously. Okay? When I press them simultaneously, I now have a flashing light that indicates I'm on page 2. So I have a couple of selections here, and you can see the defaults are already selected. Freewheel off and gov off. In this case, I'm definitely leaving the gov off, but what I'm not 100% sure on what is best for me is whether or not freewheel on or off is better. I think for my level of flying, I'm probably not going to notice a difference at all between on or off. It sounds to me like there's some cooling that can happen in some hardcore flying when you have a lot of variation in your throttle speed that will conserve and cool for freewheel on. I have a little bit more research and probably a little bit more experience to gain before I start getting into that kind of detail. And I do know people have reported active freewheel mode can be a little bit buggy or jerky for them. So I'm just going to leave it off to save me some problems. I don't want to have to rule that out as I'm problem solving build issues. So I'm going to leave it off, and I'm going to leave governor off or I'm going to leave governor off selected. How's that? So I'm going to go down to the next one. Govern mode P gain, not relevant to me. The two gain functions here, P gain and I gain, are related specifically to the governor mode. I'm not going to get into that, like I said, because I'm not using the governor, so I'm sorry. Hopefully there's another video out there that will explain that for you if you're really looking for that information. I can scroll through these two. Now I can get to startup speed. I really want a slow spool. I think that's a really cool thing, and I think a lot of people tend to prefer that. So I'm going to move this from the default of middle to heli slow, and then hit enter. Okay, next is PWM frequency, pulse width modulation frequency. It defaults at 12 kilohertz, and then what I need to do is figure out what my optimum range is for PWM. And so I use the formula to help me with that. And the formula, and I'll put it up here on the screen for you, is basically the kV of your motor times voltage times the number of poles in your motor divided by 20, and that gives you the kind of the optimum kilohertz for your pulse width modulation. So I'm running a 2000 kV motor. So if you're not familiar with kV and what that represents, and I had to look this up too because I actually made an assumption it was kilovolt because that's the other kV I'm used to seeing, but as it turns out kV is not kilovolt. It actually stands to represent the number of revolutions in 1 minute with no load on the motor for every 1 volt that's applied to it. So that's why a lower kV motor is used for higher voltage applications, because the more volts you have, the more you want to reduce the motor's rotations per minute. That way you don't overspin basically the head. So at any rate, that's what kV is on the motor. So my kV is 2000. My voltage is 22.2 because I'm using a 6S system, and my number of poles is 6. And you know, I will try and explain without visually demonstrating how to tell the number of poles. The easiest way is to look in the top of the motor, and you can see the magnets around the outside of the motor casing that spins, the part that spins. Affixed to the inside of that outside casing is a series of magnets. You can actually just count those magnets to get the number of poles for your particular motor. My motor has 6 poles. Then I take that number divided by 20, and I get 13.32 roughly kilohertz. So what I want to do now is find the setting that best matches 13.32. I have 12 and I have 14. The rule of thumb basically is that you want to round down. So actually the PWM frequency of 12 kilohertz is the default, and that turns out what is the best for my particular setting. I'm going to go ahead and hit enter just to lock that in, because I like hearing the sound that it's being done, and then we'll move on. Next thing I want to look up is startup power. Auto 2, 4, 8, 16, 32. Some people report great results with auto. I'm going to go with 2. I think a lot of people have reported that 2% auto combined with heli slow makes for a really nice spool up. So I'm going to go with that. And then basically that is it. We have done the programming on this particular ESC. And what we have now is nothing else to do. So I'm going to turn off my transmitter, and now I'm going to remove power from the ESC, and all of those changes that I've made should already be locked in. No more power, and I should be good to go. And then now what I can do is disconnect the card from the flybarless system, and then take and reconnect the ESC back to the flight barless system and then get everything mounted inside the heli. So that's it. That's a quick rundown on how to program with the programming card, the YEP, in my case, the YEP 45 amp, and we're good to go. So, and as I expected, the motor did not spool up. I was playing it safe just in case. But the good news is that did not happen. I get a little concerned when I have power applied and I have the transmitter connected and I put the transmitter into high throttle mode, that the throttle is actually going to kick on. But thankfully, through the genius of electronics, the programming card prevented me from actually spooling up the motor into high throttle. So appreciate you watching, and I'm going to be moving here pretty fast. I got the electronics to button up. I've pretty much already worked out the wiring. I just needed to get this done so that I could tighten everything down. And then I go into mechanical setup next. I'm pretty excited about that. I've actually got my swash leveling tool right here ready to go so I can level the swash. I've got to adjust the tail throw, basically adjust the tail servo, get it in the right place, and then I go into the fly barless settings again in adjusting and setting up the pitch and all that of the rotor. So man, it's moving fast. So anyway, thanks for watching. Hey, one more thing. If you're like me and you want to verify that all your settings took now that you've kind of got everything disconnected before you button it all back up again, actually I'll go ahead and pull off this receiver wire. Basically what you can do is just connect in your ESC back into the ESC connection on the card and then repower it up. Got my startup initiating tone and lights, and then you can go through and just double check and make sure that your settings took. So in this case, timing, I didn't change that from default 18, but that's where I want it. Brake is off still. As you can see, if you reinitialize, you get to see any double settings that are applied. So that was a good way to confirm that actually took. You remember when I programmed this, I was concerned because I didn't see both at the same time, but now I can see them both at the same time. Slow down in LiPo. Cutoff voltage, I left at 3.1. Number of cells, you can see it's still taking at 6, which is where I put it. No selection for number of cells on the second row. And I didn't make any real special function selections. The only thing I really can't check easily is the stop and the full speed. Obviously, it doesn't have a way to represent that to me. Again, press these two buttons at the same time. I get the flashing light, page 2. I can see freewheel is still off, and governor mode is still off, which is where I want them. Go down, P gain, I gain, doesn't matter to me. Startup speed, you can see the selection I made for heli slow, which wasn't the default selection, so I can tell that this is taken. PWM frequency, 12 kilohertz, which is where I left it, and startup power is now 2%, which is where I wanted it. So just a easy, nice way to check and make sure that your selections took if you're concerned about it. But I have full confidence that that this process worked as intended. So that's it. Now I'll catch you on the next video.